Hello everyone, welcome to my very first developer log. So pretty much I've been developing this engine for a couple months now. I feel like it's finally at a state that I can put it on YouTube and show everybody. So I started off with developing this with OpenGL in mind, and OpenGL is not really much of a ray tracer. And so still trying to figure out kind of hacky methods to get OpenGL to finally path trace the entire image and all of the voxels. Currently, it is rendering around like 1,000,000 voxels on just an integrated graphics card. So it's doing really well. Okay, so how the engine works. The engine works in a way where all of the textures, everything is represented in different three-dimensional textures. And what makes this very fast on integrated graphics card is everything on the GPU isn't just ray traced or ray marched all the way to the object. There are bounding boxes, and those bounding boxes are made out of triangles. So basically, it's like a path tracer rasterizer. So the triangles are rasterized to the screen, and as you're doing that, you're path tracing through the triangles to get to the three-dimensional geometry that you have in your three-dimensional textures. And so that's what really makes it really fast, because now let's say you have a wall that's here, and you have all of this three-dimensional texture that you need to march through to get to the wall, and then your camera's all the way out here. Well, your camera now only needs to rasterize that triangle right here, and as soon as it starts rasterizing that triangle, it marches through the geometry to get to this wall. And so you're skipping all of this extra steps that you would with just a massive three-dimensional texture that just holds all of the geometry. You can still do that in this case where you just have a bigger, really big boundary box, but it's a lot more flexible in that case. So you can have tons and tons of objects rendering to the screen, all with like intricate detail and everything. And you don't have to march through all of the space that something like an octatree or just pure ray marching would do. And that helps the engine run at around 30 FPS for like 1,000,000 voxels or so. You can actually do even more than that if you're really smart with how you manage the bounding boxes and the textures, because the lower amount of texturing that you do per frame, the faster you can get it. So it's definitely, I feel, for specifically OpenGL, a really good balance between rasterization and path tracing. So that is the engine architecture overview, at least what I'm currently at. So why am I using three-dimensional textures? So I'm using three-dimensional textures rather than something like a more compressed data structure like an octatree, is because octatrees are fairly hard to do fluid simulations like smoke and water. And that is really what I'm trying to aim for this engine, is being able to do real-time fluid and water simulations. However, there are some problems with the way the textures are handled. So currently, I'm drawing and batching everything in different intervals. So I take 16 textures and I draw them all to the screen, and then I take 16 more textures and I draw all of those to the screen. I iterate through all of the textures that I need to draw and batch them to the screen, and you can't really do any ray tracing with that. Like, as soon as something bounces, it hits off of a different texture. Now that texture is in a different batch draw. And so what I'm gonna do now is pretty much create one massive texture atlas that encompasses all of the three-dimensional textures and put them 48 or so different textures on just one massive three-dimensional texture, and have different texture slots. So basically using one texture slot for multiple textures. And so that way, everything can be drawn to the screen in one batch, and all the geometry and ray traceable objects are all in the same draw call. That is pretty much it for the engine development and what I'm working on currently. So I guess I'll see you next time when I finally implement all of that. Bye.